All right, we're good. Stream is up.
Cool. Can I get started?
Stand by 1 second.
Thank you, everyone who is just joining us now. Okay.
Okay. I'm actually going to jump in. Our MC Luke is having some technical problems. I'm Andrew with ETHGlobal, and I'm here with my colleague Luke, also from ETHGlobal, and this is the Aztec workshop, Private Trading with Aztec Connect. We have Joe Andrews from the Aztec team. He's going to be giving a talk that you guys are encouraged to interact with. So this is questions either in the stream, in the Zoom chat, or you can raise your hands and we can try to field questions as we go through. But with that, I'll let Joe take over and go from there.
Great, thanks everyone. As I was saying, we want to make this interactive. There's kind of, I'm assuming the audience is fairly technical, so I'm going to run through some slides, but I think the fun part is getting on to kind of a demo and how to actually write a bridge contract and be in with a chance to win our bounty. So let's get started. So we're thrilled to be sponsoring this week, or this 2-week hackathon. We're sponsoring a 5,000 ZK prize for the best bridge contract, which is built on Uniswap v3 and Aztec Connect. And I'll go into a bit more detail on what Aztec Connect is in the following slides. ZK DAI is just our shielded DAI, which is on the Aztec rollup. So we'll pay the DAI out kind of privately through Aztec, which is just a nice thing for us. So what is Aztec Connect? Aztec Connect is a way of talking to any layer 1 DeFi protocol or smart contract from within the Aztec network. So if you've got shielded funds on Aztec, let's say shielded DAI, ZK DAI, you can send a transaction on Aztec on layer 2. That transaction, the intent of that transaction is to talk to a layer 1 smart contract, Uniswap, Aave, really any DeFi protocol on layer 1. You're talking to the same liquidity that's on layer 1, and the benefits are you've got privacy as the source of the funds is Aztec, so everything's shielded. And the great part is that if other users are doing the same thing as you, your transaction is batched through a process of DeFi aggregation. So we can deliver 10 to 30 times gas savings for popular protocols, such as swapping and lending, all through the simple Aztec Connect interface. I talked about this previously a little bit, but just a bit more information on how this works. We aggregate layer 2 transactions for each bridge ID. And a bridge ID is pretty much just an Ethereum address with some more information around assets and kind of what is expected back. So a rollup provider will kind of aggregate layer 2 transactions, which are zero-knowledge proofs, aggregate them together, and one large L1 trade will happen on behalf of all of those transactions. I'll go into this into more detail on the next slide. But some of the high-level stats of what's possible using this flow is it's around 8,000 gas per user for the privacy side of things, and then you split the cost of the L1 transaction. So if you're doing a Uniswap trade, it's around 150,000 gas, depending on which path you take through the router. Worst case scenario, you pay 158,000 gas and it's private, you don't get any gas savings. Best case scenario, you're batched with 100 other users and you pay a fraction of the L1 gas cost, and you kind of have Uniswap trades with privacy for around 10,000 gas. The system itself can support multiple kind of layer 1 interactions per rollup. And at launch, we're targeting 256 transactions per rollup with blocks going every 20 minutes. So this should give you an idea of what's actually possible as we get closer to kind of production. Right now, we're on test network and we're trying to incentivize some really great bridge contracts to be written so that we can bring scaling and privacy straight to L1 DeFi. So as this is a Uniswap hackathon, let's go through how this can work with a Uniswap trade. If anyone's got any questions at any point, please stop me and I'll go over stuff in more detail. But I think we want to get through the slides quite quickly to get into the code. So for a Uniswap trade, let's say I want to swap ETH for DAI. A user is able to create a transaction using the Aztec SDK. They take their shielded ETH, and instead of sending it to another user, which is the current functionality of Aztec, they create a proof which effectively sends it to a bridge ID. In return for kind of spending the shielded ETH, they get what we call claim notes, which are really just pieces of encrypted value that represent a claim on the result of a future DeFi interaction. In step 2, this transaction arrives at a rollup provider, and our rollup provider bundles up hundreds of these DeFi proofs together into a rollup proof. Any proofs that are going to the same bridge ID will be bundled into kind of one transaction. And the whole rollup is then sent to our layer 1 smart contract, which owns all the funds which are inside Aztec. So currently the rollup contract just does payments, but as we upgrade it for Aztec Connect, it will be able to support all these DeFi bridge contracts as well. So if the rollup proof is valid, then the rollup contract effectively has loads of little tiny proofs inside the DeFi users' DeFi proofs that have been aggregated in a giant rollup that give it authority to send ETH on behalf of all those users to an Aztec Connect bridge contract, in this case, one that's representing Uniswap. So at step 4, the bridge contract now has a load of ETH that it wants to swap for DAI via Uniswap, just the standard kind of Uniswap v2 or Uniswap v3 swapping happening directly in a smart contract. And the bridge contract is then responsible for returning the DAI in the same transaction to the rollup contract. And the last step in this is just the rollup contract recording kind of what happened. And the reason we have to do this is because in step 1, the user didn't know quite what price they were going to get. So they weren't able to specify the amount of claim notes they were going to actually receive in terms of DAI. They just know their pro rata share of the overall transaction. So the interaction result basically lets the rollup contract record this interaction, and it allows us to kind of work in a world where the exchange rate is not known ahead of time. The next kind of block is completely, this happens automatically and without any interaction from the user. All the data to do this is already on chain and it's contained in this interaction result. But the next block, the rollup provider can create these untrusted claim proofs for every user who did a DeFi proof. And what the claim proof is actually doing, it's proving the correct distribution of DAI for every user who had a claim note for one bridge ID. So as an example, if I put in 1 ETH and someone from Aztec Charlie also put in 1 ETH, we're going to end up with kind of a claim note worth 1, and Charlie's going to have a claim note worth 1. And if we get back 4,000 DAI, exchange rates are quite bad, obviously, we both would be entitled to 50% of that. So that's kind of what the claim process does. But as I said, this happens all automatically by the rollup provider, and there's no need for the user to do anything. The user just waits for another block. This is an Ethereum block, not a Aztec block, and they will receive back effectively notes that are now worth ZK DAI on Aztec in step 2. Those ZK DAI notes are completely fungible. They can be sent, they can be withdrawn from the rollup back to L1, or they can be used in future DeFi interactions through other bridges. And the best part about all of this is that it's completely private in terms of identities. So because the source of funds is shielded ETH on Aztec, the identity of all the users are kept encrypted throughout this entire process. All you can see on chain is a lot of DeFi proofs were created. You can see the value in each DeFi proof, but you can't see who sent it or who it's going to. And if you look at kind of Etherscan, you just see the aggregate transaction. So you see the Aztec rollup contract trading with Uniswap directly and receiving DAI back. And this creates a very powerful kind of privacy set for private transactions and basically brings very strong privacy guarantees to DeFi. that was a lot of talking. So this is maybe a more pictographic representation of the same flow. These blocks here are kind of the L1 blocks. And this graphic here is just a representation of two users wanting to send ETH to get DAI back via a Uniswap bridge. So they both put in 5 ETH from their shielded ZK ETH on Aztec. This is bundled up in a rollup. The rollup smart contract then interacts with Uniswap, sending 10 ETH out. Uniswap sends back 10,000 DAI, and that's automatically distributed pro rata to each user on Aztec. We'll go over this in more detail in a second, so I think we can do this one quickly, but the way you interact with kind of the Aztec rollup contracts and a DeFi protocol is by putting a contract in the middle. We call a DeFi bridge. This basically just maps a DeFi protocol to an interface that the rollup can understand. We think we can hit most DeFi protocols this way. The interface supports up to 2 input tokens and 2 output tokens, and it can also handle async flows, so it can kind of be finalized later on, not in the next block if you want to do something like an LP position or a more complicated flow. So ideas for the hackathon, and this is where it may be useful to be a bit more interactive and take questions before we go into the code. Having privacy, we believe, enables flows that aren't really possible on layer 1 today. So this simple example is around a whale who wants to sell a large amount of ETH for DAI, let's say. If they went out and tried to do this kind of today, their options are go to a centralized exchange or an OTC kind of trader, or they can go to Uniswap. They could try and split it into smaller trades on Uniswap, but their trade intent is probably known. If you see someone who's got a lot of ETH selling units of 10 ETH over time, it's kind of obvious what they're trying to do. Or they can do a big trade on Uniswap directly. And the price impact and kind of available slippage for front running is very high in this case, which I put a sad unicorn for, because it's the one case where Uniswap is not able to kind of perform like it does for smaller users. With Aztec, we think we can solve this. So you can now do things such as time-weighted average orders. That same whale can break down their large trade into hundreds of smaller trades. And because their identity is kept hidden and the amount of funds they have in Aztec is also kept hidden, it's now possible for them to average in or out of a position over hours or days without revealing their trade intent or how much they want to buy or sell. We think this is kind of a way of massively changing the profitability of large trades going through Uniswap and helping to remove not all MEV, but identity-based front running. So you can't now front run their trade based on my other positions or kind of how much of an asset I have if you think I'm selling. So the first kind of simpler task is to write a bridge contract. We've got a bridge contract at the moment which supports Uniswap v2. We'd like to see it updated to Uniswap v3, and we'd like to see a UI kind of that enables someone to come along, create a load of Aztec transactions that allows a trader to kind of split a large trade into lots of small trades that can be drip fed into the market over time, protecting their privacy. One of the kind of key things about this ability to split it into smaller chunks is the gas price. If each of these trades was kind of costing the same as an L1 transaction, it may not be profitable to do this, but because we get batching here, the hope is that obviously if this is a liquid asset pair, other users will also be wanting to swap ETH for DAI at the same time. So this trader is kind of bundled with those other trades and gets a much cheaper kind of gas price per trade. So you can afford to split it into smaller sizes without having very high gas costs. Has anyone any questions on that one before I go on to the next one, given this may be something that someone wants to start hacking on?
There are a couple of questions in the chat. don't know if
I can't see the chat.
I can read them to you if you want.
Oh, there's a chat.
This one from Oleg.
Cool. So the privacy is not volume dependent. So the privacy set here is basically all the users who've ever deposited the source asset to Aztec. So if you're kind of using zk-ETH in your bridge and you do a user does a transaction that kind of takes their zk-ETH and sends it to Uniswap, as long as the amount of that transaction is not like astronomically large, their privacy set is all of the deposits into Aztec. And those could be deposits for payments, could be deposits just for mixing, or deposits for other bridges. So the more bridge contracts there are, the better the privacy set is for everyone, but it's not dependent on the number of users in your particular batch or in that particular bridge interaction, if that's helpful. And the second question, the whale could split his ETH across multiple wallets. I guess the way you would do that is either out from Coinbase. So Coinbase is basically the largest centralized mixer. So you could set up loads of unique wallets and fund them each from Coinbase, or you could use Tornado Cash or the current Aztec system, which is about 50 to 100 times cheaper than Tornado Cash to kind of make these fresh wallets. But it's a bit of a user experience nightmare. You have to kind of keep track of all these wallets, make sure you don't dox yourself or accidentally link them. So we think this just provides a much nicer way of doing this through an SDK and completely decentralized. It's a good point. The bulk Uniswap trade would be more susceptible to front running. There's a couple of things. So you can use flash bots, and that's kind of one thing we're looking into. You also have kind of a larger collective bargaining power because there's multiple users in the rollup. You can effectively pay more per unit of gas. You can pay more per unit of gas for a transaction because there's more users. But you're right, the rollup is susceptible to front running. One advantage, and this is kind of leading on to the next idea, is that if you have a bridge contract that does ETH DAI and DAI ETH, the naive way of doing that would be doing two large trades on Uniswap, but you can now write a bridge contract that nets the two. So the only thing that can be front run if you front run the roll up is the delta. So if kind of more ETH is being bought than sold on Aztec, then you can front run the difference, but you can't kind of, the only way to get in on that transaction is actually to be part of the Aztec network and have a DeFi transaction. The only thing that is not private is that a specific address is interacted with Aztec. You can see that a specific address is deposited to Aztec, correct? You can't see what that address has done in Aztec. That's correct. You also can have addresses that are kind of fresh directly in Aztec. So you could potentially do kind of private on ramps, private off ramps if you didn't want to have the kind of layer one deposit. I'll come back to the roadmap question later, and we can go into the more exciting kind of but slightly more difficult second idea we have. So the second idea kind of it basically was we came up with it because of some of the front running problems that could happen if the roll up is incredibly successful and there's large Uniswap transactions happening. And it's taking advantage of limit orders with Uniswap v3. So Uniswap v3 enables kind of two types of limit orders, which are expressed as single tick kind of LP positions. So you can kind of have an order where you're taking profit. So you've got ETH and you want DAI, and you want that to happen kind of above the current price range. So let's say the price is at 1,500 and you want to sell when it gets to 1,700, you can kind of provide out liquidity for that range, and you can end up with DAI. Obviously, if you think ETH is going to crash at some point and then rebound, you could put like a limit order in to purchase ETH, let's say at 1,200. The price was 1,200 DAI. So those two types of limit orders are possible today on Uniswap, but they have some problems. The main problems are you have to enter into an LP position, so it's expensive, not really suitable for kind of everyday users. The position must also be exited whilst the price is in your target range. So if the price goes on the right up to 1650, but then comes back down to 1500, you'll receive trading fees, but your position will be back in ETH again, which is not what you wanted to do for your trade intent. So you need to kind of act quickly and monitor your positions, which costs a lot of gas. Secondly, everyone can see your limit orders, and they can kind of see, they can link different strategies together again, which is not ideal if you're kind of trying to do hedging or kind of any other kind of types of orders. So we think that Aztec Connect can also solve this. You could kind of, if you're a large whale, kind of do these limit orders, and you probably wouldn't mind paying the gas fees to transact as an LP and then exit the position. But if you're trading kind of 1 to 10K in USD terms, the gas costs really start to eat into the kind of overall transaction price. So the idea here is that you can create Aztec Connect bridge contracts that for a given asset pair, so let's say ETH DAI, set up these single tick LP positions for popular kind of ranges, and they do that on all the users, on behalf of all the users who entered into that particular kind of bridge ID. So the effect here is that lots of users can club together, and in terms of the roll up, they look like a whale. It's a very large trade. It's a very large kind of LP position. In the example here I give, we have 10 trades of 10,000, and the economics suddenly flip on their head, so that you can do very interesting things like incentivizing a keeper to automatically close the position when it's in range. So the idea here is to write a bridge contract that helps users, effectively like a private limit order exchange, where the identities of all of the people in the order book are hidden, but you use Uniswap v3 to process the limit orders and maybe chainlink keepers or other keepers to incentivize the closing of the positions with the liquidity fees that you get from being in the position. And I did some kind of back of the envelope sums down here to work out that this is actually including paying chainlink keeper gas costs at a pretty high gas price. The trade is still profitable. So it'd be quite nice to kind of have a system where you can set up these limit orders or take profit orders for large amounts over time using Aztec Connect bridges. This one is a bit more complicated, but I'm happy to take some questions on it. Oh, some more questions here. How expensive in gas is Aztec proof checking? So validating a roll-up costs around 400,000 gas, and we can fit between 256 and 512 transactions inside that. At the moment, we're working to expand that pretty drastically. The important thing here, though, is you don't need to fill the whole roll-up. So we have payments happening at the same time. We have different bridge interactions happening at the same time. So at launch, we think that we can get the cost of being in the rollup down to around 5,000 to 8,000 gas for a DeFi interaction. So if you write a bridge contract, the only thing the user has to pay is the cost of the L1 bridge contract and 5,000 gas for doing the proof. We're going to be running blocks every 20 to 30 minutes at launch, but there's nothing stopping us kind of, if we have the transaction volume, running blocks every kind of Ethereum block. It's just a case of getting a flywheel going and making there be enough transactions for everyone to make those profitable. And proof generation happens on the client. This is private, so you create a little proof in your browser. Takes about 10 seconds, about 5 to 10 seconds, depending on the device. The rollup also has a proof generation cost. It's about 2 to 4 minutes, but we haven't really parallelized it right now. It's not the bottleneck. How long do I have? Do I have time to go into kind of a demo and code? I know that went on a bit longer than expected.
Yeah, you can keep going. There's not another workshop right now. There is a quiz night if people want to go, but you can keep going.
Cool. Well, let's do an example of this working on Gurley, the test network, and then I'll post a link to this starter kit we set up, which is basically just a Solidity contract that you can, and some test files that you can change. And if the test passed, your bridge is working. The goal for the hackathon, I think, is to submit a Solidity contract, and by the end of kind of 2 weeks, we'll then get that deployed on Gurley and working with the testnet rollup. So cool. This file here is on our GitHub under, this is kind of using our SDK. It's using a slightly older version of Aztec Connect, but basically it's using an already deployed Uniswap v2 bridge. And it runs through kind of some of the flows. So what I'm going to do next is take some ETH. I'm going to shield it on Aztec, end up with ZK ETH, so 0.2 ETH here. Wait for that to settle, and then I'm going to do a DeFi interaction to swap DAI privately using Uniswap v2. The way that works is we've got this Uniswap bridge contract already deployed. I'll just run this, and then I'll take a little bit of time for these to actually process because the test machine is not our big rollup server, but we can look at the Etherscan output and see what you can see. Demo gods. What's up here? Oh, maybe this is not going to work today. What did I do wrong? One second, sorry. One second. I think I got my this demo private key wrong. Oh, we'll switch to the other one. And maybe something that got corrupted on my VS Code. I'll come back to that one in a second. So we have this repository. I'll just post it in the chat so everyone can see this. if you find the bug, it depends where the bug is. This is the starter repo for kind of the docs as well, of like how a bridge contract works, and it has kind of some test cases and an example kind of Uniswap v2 contract. So I'll go through this on my VS Code, but yeah, I'll just switch across actually. So we've got inside here in the source folder, we've got a Uniswap bridge test. And what this does is it simulates the Aztec rollup calling a bridge contract. It calls it with kind of different assets and different amounts, and it expects the bridge proxy to receive assets back. So it's actually quite a simple interface to write the contract. You just need to write stuff in Solidity, and all of the kind of zero knowledge and rollup cryptography is abstracted away. The way developers kind of and users actually end up interacting with this is via the SDK. You create a proof that kind of you send to the rollup, and then that lets the rollup actually call your bridge contract. But this kind of starter kit doesn't worry about any of that. It just mocks this effectively. So what this looks like is, in this case, we have a Uniswap bridge, and this uses v2, but it's quite a simple bridge. It's basically, at the moment, only has support for swapping ETH to a token and a token back to ETH. All of the bridge functionality happens inside this convert function. This function is called by the Aztec rollup contract through our DeFi bridge proxy contract, and before this point, you can assume basically that the Aztec rollup contract has sent you ETH if your input asset is ETH, or tokens if your input asset are tokens. And as before, you can specify 2 input assets and 2 output assets. And this function should basically do the work of interacting with the DeFi protocol, and it needs to transfer tokens back to tokens or ETH back to Aztec, and tell the call of this function how much you've returned. So in this example, we only have 1 output asset and we only have 1 input asset. So we're taking ETH and we're swapping it for DAI. And I can run that just by doing this. So we'll kind of spin up a local Ganache. And it's just going to run the tests. This is kind of the very simple flow. There's a few things in the interface which I'll go through in a second, which I think are quite useful for kind of more advanced flows, such as private limit orders or other things. So the main one is this Boolean. Let me go to the interface, actually, it'll be easier to talk through. So this Boolean down here is async. Basically tells the rollup contract if it should expect the results back from this interaction now or in the future. If it happens in the future, effectively what the user's done is it's sent these assets into the bridge contract, and the bridge contract owns them at that point, and it can put them as an LP position in Uniswap. It could buy an NFT, it could do lots of things, but in this case, it's in the limit order example, it's going to open up a single tick range position. How it does that and how it knows what to do, it's got the kind of input asset data and output asset data, which tells us kind of, if we look at the types, we can kind of see that these are asset types are kind of ETH, ERC20, or virtual, and we'll come on to what virtual means in a second. But go back to the interface. It also has this AUX data field. So you can use the AUX data field to basically specify kind of your price effectively. And this is all done via the client or the SDK. and ends up in the bridge contract. So in this example, if we wanted to do the limit order, we would return async being true, which means these values would be 0. And then at some point later on, when the position was in range, you could set up a keeper to kind of call can finalize with the ID of this particular interaction, and also call the finalize function, which actually returns the values back to the rollup. So you can think of that as like the actual settlement. So when you've exited your LP position, you've got the die back, you need to send it back to the rollup, and you need to effectively disperse it back to all the users who participated in that particular trade, let's say. So the goal for the hackathon for us is that people kind of take this project and come up with their own bridge contracts, and we'll be awarding this 5,000 ZK DAI prize for the best bridge contract. I'm around in the Discord to answer questions. I've got lots of ideas on, I think, how this could be used. I think it's quite a new primitive to bring to kind of Uniswap, and we're excited to see what people build. Maybe take some more questions. Does this mean a bridge is needed for every Uniswap pair? No, it doesn't. So I guess like challenge 1 would be to enhance this current bridge contract to make it such that you can reuse the same bridge contract for kind of multiple assets. At the moment, we kind of can do ETH to any token or any token back to ETH. We couldn't do kind of token swaps just in this bridge contract. The interface itself supports it. You can have any input assets and any output assets. In terms of batching, I'm not sure if that was the question, but your batch will only obviously be batched with kind of your asset pair. So you can share in the same rollup as multiple different bridge interactions. But if you're doing kind of ETH DAI and I'm doing ETH BTC, that's going to result in 2 bridge interactions in the same rollup. So you only split the L1 gas cost with people who are doing your exact bridge interaction. Let me try and get this other example working because it's more fun. I'll take some more questions in the meantime. I just have to stare at this for a while. It was working 5 minutes ago. Has anyone got any other questions? Oh, what's going on here? ETH's project wallet. Ah, I know what's wrong. Sorry. Give me 1 second. Forgot to put in my new private key from MetaMask. You can see this one because it's a fresh account. Yay, there we go. Cool. So this is our SDK spinning up. It has to create. This usually runs in the browser, and this is kind of just a TypeScript SDK. This is how your users eventually will interact with your bridge contract by creating a bridge ID with your kind of address. The first step here is, as you can see, if this is big enough, I'm going to deposit my 0.2 ETH. So I create a join split proof, which takes my 0.2 ETH and converts it into ZK ETH. So the proof takes a little bit of time to create on the client, and then it gets sent to the rollup. The rollup on testnet is quite slow, and it only handles 2 transactions at a time. But we can kind of wait for this to settle. And at that point, we have ZK ETH, which we can use in future join splits or DeFi bridge interactions. So whilst this is settling, maybe I can take some more questions. How is Aztec staying more long term? Yeah, so every user pays a fee for their transaction. At the moment, it's kind of a break even, but the long term kind of model is that rollup providers will earn kind of fees from their users. So you can see in the code right now, every transaction has a fee paid in the assets that you're transacting in. At the moment, it's kind of there's no markup on that fee, but longer term, there would be fees there. As protocol owners, we could take some of that fee. It's kind of sustainability long term. We head over to ETHScan. So this is our roll up on ETHScan. I believe this was my deposit transaction. So as someone mentioned earlier, you can kind of see that I interacted with this. I put 0.2 ETH in. But after that point, it's kind of hard to see what's happened. There's not a very big privacy set, obviously, around the test network, but there's a much larger one around mainnet, which is growing every day. So in a second, our rollup provider will spit out a rollup, and I'll get my ZK ETH, and then we'll kind of be able to use that in a bridge contract. 1 second. So there's the pending rollup. And once it's settled, the SDK kind of automatically decrypts it. And you can see here that in the logs, I've got an encrypted value now inside Aztec worth 0.2 ETH, denominated in way. And now what the user is going to do is buy some DAI by swapping on Uniswap privately. So we created the proof, added a new DeFi transaction, and we have to wait for that to settle as well, which will be another roll up. You can see here, this is the roll up one. To save time, I may just go back to an earlier roll up. I'm not sure how long we've got, but so we'll see one of these in a minute. But what you can see here is, I think this was for 0.4 ETH. It was a different transaction, but we swapped 0.4 ETH for WETH to interact with the Uniswap router. This is through the bridge contract I showed you earlier. And then that was swapped against test DAI with a terrible exchange rate, because I think the pool's not configured correctly. So this test DAI basically came back into the rollup contract and was dispersed to the users with a different asset. So you can kind of see an end-to-end bridge interaction here. The rollup provider on testnet is kind of small, so it doesn't do that many of these, but you can imagine with the 4 machines, kind of multiple bridge interactions with hundreds of users, this becomes a pretty great hub for kind of private trading and private DeFi. Any more questions? Yes, so this is our this is the test rollup that the SDK is connected to on testnet. We've changed the interface slightly on this one. So if you write a bridge contract using this like starter kit, we'll be deploying a new kind of beefier girly machine that has the new interface towards the end of next week. So if you're writing bridge contracts, you'll be able to kind of test these things a lot quicker towards the end of next week once we've upgraded the machine. Yeah, so I think if you're planning on writing a bridge contract that takes advantage of this, I'd start in Solidity. For me, it looks like if you interact with any underground assets, you would dox yourself. Can you explain what you mean by that? Sorry, maybe on voice or in chat. I'll keep going for now. Whilst okay, I'll speak to you on Discord. Great. You can see here that the first part of the process just completed. So these are the notes that give me my claim on the output. And in the second, these will be updated again. So here's the latest one that kind of swaps 0.04 ETH, sorry, for test tokens. And then there'll be a final roll up after this, which actually gives the user their encrypted DAI. All right. If there's no more questions, feel free to kind of reach out in the Discord and also in the Aztec Discord. I'll be around, so will some of our team members for kind of questions, support. If you want me to run through the private limit orders idea again, or just kind of bounce some ideas around, send me a message and I'll be available.
Awesome. Thank you, Joe. That was good. I'm glad we extended it so you got through the demos there. Also remind everyone that this is recorded, so it'll be up on the YouTube, ETHGlobal YouTube for this event. Go back to it. And I'm also reminding everybody, yeah, he can be reached in Discord in the Aztec sponsor channel in the UniCode Discord, as well as they probably have their own Discord too.
Also Telegram or Twitter, I'm here. So
awesome. I'm also linking in the chat in case you want a little something different going on right now. There's a Halloween Friday quiz night. The next 45 minutes, I think it goes. Nice. 15, 20 minutes, I don't know. So I just linked it there. All right, Joe. Thanks for the workshop, and we'll see everyone in Discord.
Great. We just finished as well. So you can see here down the bottom, I got my DAI. So yeah, thanks everyone for listening, and yeah, speak to you on Discord.
Bye.
See ya.